So, hello everyone. Welcome to this lecture, which is really, it'll start off not being about mathematics at all. And why don't I open the right project? Here we go, Gcd Maze. Here's my example maze. So here was my first attempt. Where's the messages? Oh, we're loading. Here we go. So we're in a maze. There's 5 rooms. So the rooms are called 0, 1, 2, 3, 4. And this says, I wasn't very good at it when I wrote this level, but this says you can escape from 0, right? So I'll show you what the goal is at this point. There. It means you can escape from room 0. And you see you move around like this. You can go south. We're starting there, we're in room 0. So maybe we should draw a map, right? We started in room 0. Let's put it in the middle of some area. There we go. And we've gone south, and now we're in room 2. So there's room 2. And then we go north. We go north from room 2, and we're back in room 0. And then we go south again, and we're back in room 2. And we go east, and we're in room 3. There. And then we go north and we're in room 1. There we go. And so now we can go west again to get back to room 0. So there's room 0, 1, 2, and 3. They're in a little square. And yeah, apparently there are 5 rooms. The room's called 0, 1, 2, 3, 4. When you're at the exit, maybe I should say 4 is the exit. There. So the one room we haven't found is the exit. So here we are at room 0. So why don't we go north? It says you cannot go north. There you go. So there's some barrier there. So now we know what to do, right? Now we're going to go east and we're going to go north. We can't go north from room 1. So now we're going to go east and we're going to go east from room 1. We can't go east from room 1. We're following the left-hand wall. And so now we're going to go south, I guess, to room 3. Where are we now? Oh, we're in room 2. Oh, curses. I see. So we should have moved to room 1. And so, right, we can't go east from room 1. So now let's go south. Now we're in room 3. Can we go east from room 3? We can't go east. Can we go south from room 3? We're in room 4. There. And room 4 is the one where we can get out, you see. So we use the out tactic. And it says we can't get out because we're not at the exit, which is surprising because we should be at the exit. So I wonder what I've done wrong. Did I disable some out tactic? Or will I have escaped? Ah, it's maze. I know exactly what I've done. Maze dot can escape. There. This is a preliminary API. There we go. Now out works. Out works. So we've got out. So that's a little maze game, and it's kind of interesting to see how it worked, maybe. So how did it work? Here's the definition. Actually, this is not a great example. Let's find another example. Let's look at this other maze here. Why don't I look at here? how did we make this maze? So here's the maze basically. 0, 1, 2, 3, 4, 5, 6, 7, 8, and a secret level 9. There. So I'm going to show you how I made a maze that looks like this. So you start in room 0. Have to find the secret and get to room. This is not even true. They ended up not being called this. They ended up being called A, B, C, D, E, F, G, H, I. There. And secret room J. So you started in room A, and you have to find the secret and get to room J. And W is a temp wall room, which we never go into. The idea is if a player hits a wall, I should put the walls in. There are walls all around here. Maybe we should call them W. There's W's, W's, W's. There's W's, 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 and there's 3 W's down here. W, 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 as they say. And the secret room J. One of the moves is a non-Euclidean move that doesn't take you to where it should take you to. And so here's just a random question: can people write computer programs which solve levels like this? I mean, in Lean, and can people write computer programs in Python which make levels like this? So here's how I made it. I made maze an inductive type. So this is the type of rooms. So there's rooms A, B, C, D, E, F, G, H, I, and then there's the exit room J, and then there's the temporary wall room. And then we made a direction, which is north, south, east, or west. And now here's the map of my maze. And here's what I do is here is a description of, you see, I'm defining a map from, given a direction in a maze, given a compass direction, and you're at a certain point in the maze, I want to say where you go to next. And I'm just using this because this is an inductive type. I have this very nice recursor. So we'll just enable me to write this like this. So this means if you go north from A, you'll hit the wall. If you go north from B, you'll hit the wall. If you go north from C, you'll hit the wall. If you go north from D, you'll get to A. If you go north from E, you'll get to B, etc., etc., etc. So I carefully copied this into here, and then I secretly added a special route J. And this is the map, right? There. And so can escape, this is the predicate of being able to escape from the room, from the maze. There. And so this just says exactly what you think it does. And now we make a go tactic that takes a direction and it goes in that direction. So this is kind of, and I find this kind of annoying. I would like to have north, south, east, and west. So do you think I could do those? Where is go? This is in tactic. That's in the root namespace. Can I do this, I wonder? I want to just be able to metadef tactic type interactive type of macro is not assault is going to be, am I making a tactic? I want to do, sorry, this is the idea. I want N to mean go north. Go north. There. So that has compiled. And now I just want to say N. And I have 2 errors, and I don't know where they are. Maybe I need an end. N, you hit a wall, wonderful. So that looks like it's worked. So where did I define N? Here we are. I just like these abbreviations. I want S to mean go south. There. So let me just get the bingo. So now can I go south? I should be able to go south because I can. I'm at room D. Great. So those are working. So they can become part of my armory. East and west. And I've got an out. West. East. There we go. And so now I should be able to get rid of these. This is just an experiment, really. This can go, that's just docs. So there is the definition of non-Euclidean maze, and now I have to compile it. So excuse me for a second. Where is it? Xena.maze. Non-Euclidean maze. Lean make solutions definition.lean. There we go. And now let's move the Olean file to here. Let's overwrite the old one, and now let's go back here to the non-Euclidean maze and let's play the level. And now I'm hoping that I'll just be able to say south. I can't because I'm not in the right. So where did south? This is in tactic.interactive. Oh, I'm quite surprised that S doesn't work. Oh, was I not in? Where am I here? Oh, in the root namespace. Well, go seems to work. So maybe shall I get rid of this? If I get rid of that, does this still work? Yes. So, but it still doesn't work here. Unknown identifier. Are we importing the? Oh, do I need to restart lean? Oh, great. No, what? Yes, it's worked. Fabulous. And did it work before? But I just didn't restart lean. Oh, let's try north. Yeah, so it's all working fine. So I'll leave these in tactic.interactive, I think. There. I should compile. I should move the Olean. I should get rid of that. Sorry. I should compile. I should rewrite the Olean, and I should do this. Lean restart. And it's having a think. And is that the right place? If I go west, yes, it's great. Great. So I am now going to push this example maze definition, example maze level. So fix to example maze. there, and now let's add all this stuff, and this is the non-Euclidean maze. And after this I'm going to do some maths, surprisingly, using this maze stuff. So non-Euclidean maze, so tidy up non-Euclidean maze. Oh, so I know what I was adding NSEW functionality. Add NSEW functionality to non-Euclidean maze. Right, that is all pushed. And if you want to play along, you can go to I don't know how to pin it. That's kind of annoying. Let's not worry about that now because I want to do some maths. So here is the repo. What was it called? I do this in example maze, yes. I don't know the best interface, but in fact I'll use the integers now because I want to do some number theory. So right, on to the main course of my Gcd mazes. If you want to just play the mazes, you can clone the repository. But let me make a new directory. I'm not in there. Let me make a new directory in src called Gcd Maze. And in Gcd Maze, what do we need in Gcd Maze? We need the definition from non-Euclidean maze, so I can just copy them. So let's put that in Gcd Maze. Right. And now in the Gcd Maze, I will change the definition. So this maze doesn't look like this at all. So we're going to start in room. We're going to start in room 1. Need to find our way. No, let's start in room 0. Need to find our way to room Gcd AB. There. So let's leave all this. Right, so how am I going to define my maze? So the idea is I'm going to make a maze, but I don't want my maze rooms to be this. I want my maze to be the integers. Can I do this with abbreviation maze type? I just want it to be the integers. There. So that is going to be the rooms of my maze. And now you can still move north, south, east, or west. And here we are in the namespace. And now here I have to say, what do we need here? So I want nothing like this. What does it want? It wants a maze. and that is a natural number. And so this is going north, I think. Yes, let's have a look at the direction. So this is north. Go north equals, right. Let's let go north be add 8. There. So this is just going to be m add 8, right? And then go south equals subtract 8. So this is m minus 8. No, that's not go south, is it? Oh, this isn't even working. Is this right? Let's find out. Do you think it's lambda m? Let's put lambda m there. That's south. So the idea is we're living on the integers, and now if I go north, then I'll add 8 to my location. If I go south, I'll subtract 8. And going east and west, go east equals add 3. So this is now lambda m. Lambda m plus 3, and go west equals subtract 3. There. And we can copy this. We can stick that there. That's m minus 3. And now these are in the wrong order. It should be north, east, south, west. So I'll kill the east here. And I'll dump them there. So north, east, south, and west. And now these can go. And now the escape, where we can escape if we are in room, let's say, 17. Well, no, let's say room 1. There. 1 is the GCD of 8 and 3. And then I think we can leave this, and I think we can maybe leave all of this. Is it compiling? It's not compiling. We have one error. Oh, curses, we haven't got this right. Is expected to have type maze. Is this just m plus 8? Where's the error? This looks better, doesn't it? M minus 8 has the error now. M minus 3 has the error now. The bracket error. And now there are no errors. Great. So there's my GCD maze definition. And now let's make the level. Let's just copy it. Now let's have a look at the level. So we import the definition, and now can escape A is no good. So it should be can escape 0. Solver remark, there are infinitely many rooms now. Can escape 0. Maybe we should put integer. Oh, come on, maze is equal to z. Don't give me that. Shall I make a coercion? I made it an abbreviation. Is that really no good? Def maze. What even does maze exist? It is a type. Print maze. It's a reducible inline type, so fair enough. So let's just make a coercion. Has coe from the integers to maze. Is. Does that work? Lovely. So now we have a coercion. That's the wrong level. Where's my GCD maze? Here's my GCD maze. And it still doesn't like it. So why not? For instance, has coercion from Z to maze. If I apply instance, yes please. It doesn't work. But I just made it. Did I not make it an instance? I made it an instance right here. Maybe I need to reload. It can't find the coercion. What did I do? It's a bit annoying. Let's try reducible definition. Now this compiles. And this is still not triggering. I'll just put it there. Oh, what the heck? Why is mazes? What? What is maze? Oh, it's the wrong bloody maze. I'm importing the wrong thing. Ah, bingo. Bingo. Ah, we're in a maze of integers. All distinct. There. North adds 8 to your integer. South subtracts 8. Right? East adds 3 to your integer. West subtracts 3. There's no wall. When you're at the exit, type out. We don't need to do that. You start in room 0. By Bezout's theorem, you can get to room 1. The exit is in room 1. So let's go. Let's see what the goal is. Can escape 0. And if I go north, oh man, it doesn't simplify it. Norm num. Norm num works. So maybe I can insert these. Unfold maze.go, norm num. Let's try that. Great. Now we're in room 8. And if we can go south, and we're back in room 0. North. North. There you go. So I can keep adding 8. And if I go west, what does west do? West is subtracting. West is subtracting 3, so I can go west, 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 west. And now I'm back to 0, so I'm back to square 1. So the question is, so Bezout says that there exist integers lambda and mu such that lambda times 8 plus mu times 3 is 1. You see, that's what I want. So I think that lean has these, right? Check Gcd. What does this do? Is there a nat one? Have we got a nat.xg? Maybe I need to import it. Is that a thing? I don't know how to get the extended common divisors. Let's search. I'm pretty sure it's called Xgcd. Is it Xgcda or something nonsense? There's a PNAT Xgcd now. Euclidean domain Xgcd orgs. There's an int. This is the one I want anyway, isn't it? Is int. I'm a twit. I want int.x. And it's in data int GCD. Data int GCD. And it'll no doubt be constructible. Really? Still no? Is it in the root namespace? I don't get it. What is this? Right, where does it live? Data int GCD. Have I not imported that? Yeah. Where is my Xgcd? There it is. Xgcd. nat.xgcd. It is called nat.xgcd. And it's finally working. Great. So nat.xgcd 8 and 3. So I need to eval it. Eval nat.xgcd 8.3. And it finds it's -1, 3. Right? So that means subtract 8 once and add 3 times. So here's how we do this level. We add 3 times. Which way was east? Adds 3. So east, east, east. And now we're at can escape 9. And so now I want to go south. And now I'm at can escape 1. And I should be able to get out from there. There we go, goals accomplished. So now I've solved that level, but I can make that level harder because we don't need that anymore, I don't think. What we can do is we could make go take 2 more variables, right? A and B, in nat, if you like. There. So now, north equals add A, south equals -A, east equals add B, west equals -B. There. So this is now add A, add B, no, yes, subtract A, subtract B, subtract B, and now it can escape. I think I want this to be, I think I need 2 inputs, A and B are going to be naturals. I'm going to have infinitely many mazes, right? Do I really want to do that? Maybe not. A and B are naturals. Has Gcd Maze AB there. And now Maze AB. Do you know what? These should be parameters in here, shouldn't they? Why don't I make them parameters? That would be an interesting thing to do. Parameters A and B, and they can be naturals. No, doesn't like the look of it. Okay, let's forget it. No, maybe let's put it in a section. Parameter A, B. Parameters. A and B. And they're going to be they're going to be naturals. And we maybe make them implicit. I'm just not really sure. And now go. We can just get rid of these now, I think. There. And now this doesn't work. I want maze to have the parameters. Where's my definition of maze here? What about that? Can I get rid of that? There. Now I can maybe even get rid of that. We're still not compiling. This can go down here. Let's get rid of them. Oops. There. And now I have 15 errors. What's wrong with my... Why have I got an error? Oh, because I've got... Have I finished with my parameters now? Let's see if this is a disaster. Oh, I have no errors. But now does it actually work? It wants, so now let's put 8 and 3 in here. Oh, look at that, it compiles. There. I've made a maze on the hi Chris. I've made a maze on the integers. You can go north, south, east, or west. Oh, yeah, I don't know, but this isn't right, is it? What's can escape.exit? This is not right. This should be GCD. This should be GCDAB. Right? I need some. I need to. Is there some nat.gcd? Can escape. This shouldn't be a 1. There. You see, you have to. I think that should be fine. So now you have to. Let's try an example where the GCD isn't 1. So let's try 8 and. I don't know. Let's try. Let's try 6 and 10. There. The GCD of 6 and 10 is 2. I wonder if we can make those. It's a shame that it says can escape 6, 10, 30. We make some notation. Don't know. How do I make this local notation work? Am I not allowed spaces in notation? What am I trying to do? It's can escape. Can escape. It's not the keyword. It's the unexpected space. It doesn't like the spaces for some reason. Sorry, Xing, I didn't understand. Aha. Chris didn't like the sound of it. But it's still not doing it. It's not picking up on it. Oh well. Let's see if we can get out anyway. The GCD, we need to check we better find where the solution is. Check GCD of 6 and 10. This is nat.gcd. So the exit, oh, I need to eval it, of course. I don't believe in eval. Eval says 2. So we need to get to room 2. And we are in room 0 and north adds 6. I can do it, it's easy. North adds 6. So I go north twice. And then east adds 10, so I go west. And now I should be out. Goals accomplished. So there you go. So I've done that level as well. But I can't make the notation work. I can't make this work. And so now the question is, can I do something ludicrous? What about theorem, solve, can escape? I don't know. No. Some huge thing. Oh, this is what? Why doesn't that give me an error? Because I've got something called sorry. There we go. This is an example. This isn't a theorem. I mean, it is a theorem, but they should be theorems. There. So now can we get out of this maze here? So the first thing, let's see if we can use lean to get out of this maze. Eval nat.gcd. This thing here. So the GCD is 1. And so now we need to eval nat.xgcd. And so my understanding of that is we need to move this one here. So is that too much? So we need to move 1075 times. We need to move south 1075 times. Oh, what's the syntax for repeat? Repeat tactic, repeat. I could have sworn there was a way of doing some iteration. Oh, is it iterate? Here we go. And now look, it's timing out. So I think these numbers are maybe too big. So let's make them an order of magnitudes. What about, I don't know, 20 and 77? Oh, I was even doing the wrong one. There, let's try 20 and 77. So we want to eval nat.xgcd. The GCD is 1, right? It's 2077. The GCD is clearly 1 because the prime factors are all different. So it's 27, negative 7. So can I do repeat? I want to go 27 north. No, iterate 27 north. And this might terminate in some finite time. And then I want to iterate 7. I want to go west, I think. And then I think I'm out. So there you go. Will it compile? It's compiled. And I'm out. So there you go. Oh, I should put the full stop here. So solving this maze, you don't really think about it as a maze game because it's the integers, but in fact this is exactly Bezout's theorem. So in general, given two numbers as an input, which numbers can you walk to? So in general, you see that would be a theorem that one could prove, right? One could try and prove that. Example, so A and B would be naturals. And this would be a theorem. I mean, this is a theorem, right? This is a challenge. If A and B are naturals, the challenge is: can you escape? Can escape A, B, 0. There you go. And this was working. I should put the Gcd version. So it's 1. There we go. There's my challenge. There's my maths challenge. Can you prove Bezout's theorem in lean via mazes? And I think that's probably quite a sensible place to stop. So I'm going to clear off to the Discord. Thanks for everyone that watched all summer. And goodbye.